Hi! In this video we are going to present Unit 4 of the ARIS course. This unit is focused on deep learning for natural language processing, also called NLP in brief, and on big data analysis. The material of the unit has been developed by Leandro De Persis, Fabio D'Amore, Mario Merone and Gianluca Baldassarre from the Institute of Cognitive Sciences and Technologies of the Italian National Research Council. Unit 4 is divided into 6 lessons. In lesson 1 we will introduce the main concept of NLP. We will start by mentioning how NLP is linked to artificial intelligence, to then arrive to illustrate the specific deep learning approach on which we will focus on this unit. In the lesson, we will first explore in depth the fundamental concept of embedding that allows the encoding of language, words and sentences in ways that can be processed by neural networks. Then we will present its advantage and some tools to implement it. Afterwards, we will explain how to make a text classifier by highlighting the critical aspects of the problem and explaining code examples in detail. Then we will show both how to train a new word embedding together with the neural network, and then how to use a pre-trained one that can be possibly further refined. In lesson 2, we will approach the main machine learning tools to face NLP problems, presenting and practicing with their main functions. First, we will introduce the main Python libraries that are focused on NLP. Then we will review convolutional neural networks and apply them to NLP problems using embedding techniques. Next, we will introduce recurrent neural networks, see their different types, consider their pros and cons, and look at some of their late developments towards attention mechanisms. We will then review the basic concept of reinforcement learning, such as the policies and value functions, and see how these can be applied to natural language processing. Finally, we will also see how to use unsupervised learning techniques for NLP problems that do not have labeled data. In lesson 3, we will explore some new approaches of NLP that in the last few years have produced better results than traditional approaches in specific NLP applications. Initially, we will see character-level NLP embeddings in which the fundamental token is not the word, but a single character. Then, we will introduce the transformers that are based on previous concepts related to attention mechanisms. Following, we will consider Elmo and BERT. These are more complex models that, for example, can project sentences into vectorial spaces to represent words and contexts. Finally, we will also consider some aspects of the ethics of machine learning as related to real-world NLP applications. In lesson 4, we will open the important chapter of big data analysis. Starting from the 5 Big data paradigm, we will discuss the main application of big data analysis and relate it to business intelligence. Then we will give an overview of MapReduce, a framework to support the distributed computation of a large amount of data in computer clusters. Subsequently, we will explain Hadoop, an open source framework inspired by MapReduce for writing and executing applications distributed on machine clusters. Finally, we will introduce Spark and describe first its link with Hadoop, and then highlight its properties and advantages. In lesson 5, we will then expand the basic concepts of Spark and analyze its main components and functions. We will then discuss the execution mode of Spark, the cluster managers, and PySpark, which is the Spark shelf interface for Python. In detail, we will work with the data framework APIs such as data frame operation and manipulate process. In lesson 6, we will discuss the main aspects of cloud computing and how this can serve big data analysis. After that, we will introduce Databricks, a platform for running Apache Spark that provides automatic cluster management and IPython-style notebooks using Spark. Finally, we will analyze the main components of the machine learning pipeline using Spark ML. In particular, we will explore some applications of the Spark.ml package for classification, regression, and clustering tasks.